Hello.
Yeah, go ahead, sir.
Yeah. Uh, Good afternoon, dear members. Yeah. Good afternoon, dear members. Our esteemed speakers, my senior colleague, Mr. S. Manohar. A hearty welcome to all of you in today's web seminar on robotics, sanding, buffing, grinding, and polishing, the surface treatment using active compliance technology, being organized by the German Engineering Federation, VDMA, along with Ferrobotics. We hope all of you and your families and employees are safe and sound, doing well. I'm Sandeep Roy, based out of Calcutta office of VDMA, and we'll be taking you through the initial part of today's webinar. Friends, robotics and manufacturing are a natural partnership. Robotics play a major role in manufacturing landscape today. Automated manufacturing solution should be a key part of operation that strive for maximum efficiency, safety, and competitive advantage in the market. Manufacturing robots automate repetitive tasks, reduce margins of errors to negligible rates, and enable human workers to focus on more productive areas of operation. Robotic production automation in manufacturing allows companies to remain competitive globally, offering an efficient, viable alternative to offshoring and fulfilling skill gap in areas where it may be of difficult to recruit the necessary employees. The automation of the production is accelerating around the world. 74 robots units per 10,000 employees in the new average of global robots density in the manufacturing industry. By region, the average robot density in Europe is 99 units, in America 84, and in Asia 63 units. Robots are moving from controlled environments to uncontrolled environments, and from select industries to every industries faster than we could have expected. Thanks to the new normal caused by the COVID-19 pandemic, robots are now more critical in business and society than ever, as businesses and governments search for new contactless solutions. The pandemic is strengthening the case for robotics and automation, as robots are already being used by the companies to engage and delight customers, solve logistics difficulties, or take the difficult and dangerous tasks. Ferrobotics has an intellectual vision towards robotic automation and wants to optimize the different aspects of automated physical contact between machine, product, and the human, forming itself as an essential component of both industrial and social life. Its patented active compliant technology ensures that tactile sensitivity is present in robots to make them agile, robust, more flexible, and reliable, all at the same time needed for a form of a surface treatments, especially in the automobile, general industry, and aerospace sectors. Friends, against this backdrop, and to keep abreast our Indian manufacturing industry with the latest information on the subject, I would like to introduce and welcome a very illustrious experts joining us in today's web seminar. We have Mr. Thomas Conrad, Vice President Far East Asia, Ferrobotics. Unfortunately, Mr. Michael Humer, Executive Vice President Asia, could not make his presence because he is unable to join due to some medical issues. Friends, we have Mr. Raghu BN, the next speaker. He is the representative India and the Director Application Consultancy, Ferrobotics. Welcome, Raghu. Mr. Tarun Khurana, Director Nextgen Robotic Automation from the System Integrator of Ferrobotics in India. Hearty welcome to Mr. Khurana and Mr. Conrad also.
Thank you.
Friends, moving forward, I have very brief about VDMA. VDMA is the largest industrial association in whole of Europe. Established in 127 years back, VDMA has more than 3,300 members at its fold as on date. The members employs around 1.03 million employees, which produce around hoping 232 billion worth of production, out of which 78% are exported. Friends, sensing the importance of the Asia regions, VDMA established its first foreign offices in India way back in the 90s. After the success of establishing the India office, VDMA later established in China, followed by Brazil and Russia. VDMA has also foreign offices in Japan and all the European communication offices in Brussels and Belgium. For the ease of operation, VDMA is divided into 38 engineering verticals, starting from agriculture to woods. Friends, before we move, I would like to remind all of you that you can post all your questions during the webinar under the question section, and that will be answered during the Q&A session. Now, I would like to briefly introduce all our three speakers, starting with Mr. Conrad. Thomas holds a mechanical engineering degree and a vast experience in sales of high technical demanding industrial machinery and goods. He joined Ferrobotics family in 2018 and is responsible for Asia Pacific business based out of Bangkok, Thailand. I welcome Mr. Raghu Bien, who is an electronics engineer, worked with Fanuc in India for last 19 years, know-how for CNC and servo control systems, robotics and automation and integration. He has been taking care of the Ferrobotics product sales, partners coordination, and application consultancy for Indian business since 2018.
Thank you.
Thank you. And Mr. Tarun Khurana. Mr. Khurana is also a mechanical engineer. He worked with Yasoka in India for 12 years. He has expertise in robotic automation, integration, started robotic integration company Nextgen Robotic in 2015, supplied more than 200 robotic systems to various automotive and engineering industries. He is an authorized integrator of Ferrobotics since 2018. Now I invite Mr. Thomas Conrad for his keynote address on Ferrobotics for around 5 to 7 minutes. Over to you, Thomas.
Thank you very much. Very good afternoon to everyone, or let's say this time so nice to meet you. First of all, of course, Mr. Sandeep, thanks for your introduction, but also thanks to Mr. Manohar for setting this up, and of course to Tarun, our valued partner, and also Mr. Raghu, who will give you later a better overview of Ferrobotics. And yeah, I'm actually quite happy to be able to talk to you and that we have the opportunity to host this webinar. I'm quite sure in front of an outstanding audience in terms of audience of industrial professionals. And yeah, I would just want to give you a short heads up what Ferrobotics is doing, what Ferrobotics stands for. So basically, we are an Austrian-based company which was established by Dr. Naderer, who is the mastermind behind our technology and, or let's say, our unique and highly advanced technology. And he is also, of course, acting as the CEO of our company. What is also a very important factor in our company is the international focus and our customer-oriented working principles. That's why we have several branch offices around the globe, as well with in India with Mr. Raghu, where we are also making everything possible to be close to our partners and to give them the best support possible. Oh, sorry, I just have some issue. Okay, so basically, what we do, what Ferrobotics does, we are not only the market leader in so-called active compliant technology. No, we are more than that. Actually, we are the inventor of this technology and a pioneer in this field. Active compliance technology, a very fancy word. What does it stand for? Well, it's basically active compliance technology is the foundation of sensitive robotics in the field of force control. Force control, well, in case if there are some Star Wars fans here in the audience, don't be disappointed, it's not about that, but our technology is even better than that, I would say. So what is ACT, active compliant technology? Well, with the active compliant technology, we are setting new standards in the field of force control and enabling all kinds of applications in industry automation, which were so far very hardly to achieve or basically impossible. That means our aim is to give a robot a sensitive touch, a human touch. Means we make them feel, and by that we are closing a very big gap in automation. All of you know about robots. Robots are very precise devices, but also very dumb devices. They cannot feel, they cannot hear. And that's a big issue. And with our technology, we can overcome this. Sorry. So that means by bridging this gap, we are now just open up not new possibilities for all kind of automation jobs, and especially jobs which were so far handled by manual labor for several reasons. But one of the main reasons, of course, robotics were simply not sensitive. With Ferrobotics, robotics is now sensitive. And we are not just getting rid of manual work, it's even more than that. We are increasing the reliability, we are increasing the quality, and of course, we help you to save costs, which is an important factor as well. And in these days, there are also a lot of jobs which requires automations, which are dusty, dirty, dangerous, which we are always calling the 3D jobs. And these jobs anyways have no big appeal to humans, and people don't want to do it because they're dangerous, they're dirty, it's dusty, and it's hard to get qualified staff, qualified labor who is willing to do that job. And in this, for the applications or whatsoever, of course, much more later on from my colleague, from my valued colleague, Raghu. And yeah, at last, I would like to give you a glimpse about what industries we are working in, what we are doing, what is our main focus. Of course, big market for us is the automotive industry, where we are quite successful, but also many other transportation-related segments, no matter if trains, aerospace, or whatsoever. But besides that, we also have many installations in the general industry. General industry, well, that means it's quite a general term. What means general industry? Well, basically we do everything from grinding of welding seams on a tank down to polishing gold jewelry or accessories. So you can see there's quite a wide range of fields and applications we are working in. We are also having many installations in the wood industry, in the glass industry, industries in ceramics, maybe for bathroom or other applications, or stainless steel, you call it. There are so many possibilities you can do, you can automate with our technology that it would take hours to list everything down. So basically, it's always say we can do not everything, but almost everything with our technology. And yeah, as I say, you will get a much more detailed information from a valued colleague, Raghu. And for the moment, I just can say thank you for your attention and that I had the chance to give you a short introduction about the company. And I give back the virtual microphone to the guys from VDMA, and thanks once again for your help, and thanks for your attention to the audience.
Perfect. Thank you, Thomas, for our very interesting insights. May I now request my senior colleague, Mr. S. Manohar, to take over the proceedings. Over to you, Manohar.
Thank you. Thank you, Sandeep. Thank you, thank you, Mr. Thomas. That was a very interesting, insightful presentation, especially on the technology of ACT, what you call active compliant technology, which Ferrobotics has pioneered, and also the benefit it provides in terms of flexibility for robotics as an attachment tool. But more of that would come from Raghu, who is going to talk in depth detail on the application of Ferrobotics to the wide section of the industry's applications. So Raghu, over to you. I will give the controls to you so that you can take over and give your presentation. Yeah, there you are. It's off to you.
Okay. I think while I'm preparing, you would like to run a poll question, first one?
Yeah, I will do that poll question first across. Yeah, true.
Yeah.
Dear friends, we will run the first poll question to you all, and the first poll question is coming on your screens now. There you go. So the first poll question, we request to know more about your inputs on this. In your opinion, labor-oriented and skill-dependent surface treatment applications need to be automated. Do you all agree, disagree, or not sure? Yes. Let's give few more seconds to close. Okay, here I close. Yeah, there you can see the results. 95% agree, but Raghu, the challenge you have is the next 6%. So you need to have to convince the people by the end and convert them into 100%. So there you go across.
Absolutely, absolutely.
Yeah.
Looking forward to. Yeah.
Okay.
So will you please pass on the controls?
Yeah, yeah. There you go. Yeah, here you get it. Yeah.
Okay. So good afternoon, everyone. Thanks to Manohar and Sandeep for a fantastic start of this webinar. We are very delighted. This is the second of the series that we have been involved with VDMA. First webinar we conducted on 25th September, and we had a huge number of attendees attending and getting a lot of information. Now this is the second of it, and I hope to give a lot of information in terms of technology, what it is. To start with, this is a seminar about the robotic sanding, buffing, grinding, and polishing. These are the surface treatments using our active compliant technology. So as Thomas put the agenda across, we would like to talk about the active compliant technology. And here, as you understood by now, we are exactly having a technology which replaces the tactile sense of the humans by touching, feeling, moving, and contacts. So this is a perfect technology for replacement of the 3D jobs, which we call it as dirty, dusty, dangerous, and even the demanding high quality, high volume production, which is supposed to work 365 days in an year. So our products are built ruggedly to work throughout the year. So today I will briefly cover these topics. One is I'll talk about the company Ferrobotics. Then we will talk about the products and the working principle. And we have some videos to talk about our applications when it comes to general industry and various types of material that can be used for sanding, buffing, grinding. Then we also give you an overview of how it can be used along with cobots, because everybody today talks about cobots and also low payload applications. Then my colleague, Mr. Tarun, who is our integrator for Ferrobotics, will also unbox the unit and then give a kind of practical guide into how the product looks and how it is integrated, how it is used in a real-time application. So starting with the brief about the company, this company was established in 2006. The person whom you're seeing walking on the steps is Dr. Ronald Nutter. He is the owner and the CEO and also the inventor of this active compliant technology. So the vision with which he started this is that there has to be a physical contact between the machine, the product, and the humans. So with that vision, this product has been brought out. And as Thomas mentioned, robots definitely are very powerful. They have the highest technology, highest precision, but when it comes to surface treatments, they lack the feelings. They are supposed to be deaf and blind. This is the gap that Ferrobotics technology is, this feeling. This active compliant technology is exactly compensating the human touch feeling. So we have these products. I would like to take you through this one by one. The first one is called active contact flange. In this the product, one side is getting mounted onto the flange of the robot, and on the other side you can put an orbital sander or an angular grinder or a buffing unit or a brushing unit. The way you integrate it, you are free to do it. So this forms the basis of all of the other products that we have for application oriented approach. The second one is an active belt grinder. What you see, the unit, it looks small in the picture, but it is weighing about 750 kgs and it is about 800 mm from the ground. So it's a huge unit. This unit is a stationary one, whereas the robot will hold the component against it to do the grinding. The third one is a active sensitive kit. This is used primarily for grinding of the laser brazed joints on the roof of the car. So especially laser brazing is the procedure that has been used by high-end cars. In India, Volkswagen is the one which is implementing this on all of their models of the cars. But slowly, maybe by 2023, when the norms for the Indian-made cars will become compulsory for laser brazing, this will be very widely be used. Similarly, for brushing on the roof after the welding is done, we have ASK, active orbital kit, ASK brushing unit. And we have the active orbital kit called AOK. This is used as a replacement to the orbital sanders. In orbital sanders, when it is run by pneumatics, you get about 3000 RPM corresponding to the 6 bar pressure. In our case of AOK, we have made it run by a servo motor, so it can go up to 10,000 RPM. Literally from 0 to 10,000 RPM, you have a fine control on the speed. And because of these higher speeds, you have a very high material removal capability. And the last product is AAK. It is active angular kit. The advantage of this is again a servo driven movement. Angular, it is a replacement to the traditional angular grinders. This again will go up to 10,000 RPM because of the servo. So application wise, we have wide range from automotive to general industry to aerospace, whether it is grinding, polishing, brushing. You can see there on your screens. All the applications that are mentioned here are definitely possible. We have live experiences about all these things. So the key benefits is tactile sensitivity is what is being given by our product, and any kind of complex manual operation in terms of surface treatments which are very hazardous can be automated. And the precision and the quality, this is basically meant for mass production, high precision applications. And the value add that you get is finally you get savings on lot of costs, whether it is in terms of consumptions pattern or in terms of the cycle time, in terms of the quality aspects, in terms of reduction of the rejections itself. You get a huge cost benefit when you implement automation with our active compliant technology. So these are some of the references of our worldwide customers: BMW, Audi, Mercedes-Benz, then Volkswagen Group, Renault Group. All these are our customers. So worldwide, we have a lot of presence, including India. India operations started way back in somewhere around 2018 early, and we have been going very strong in India as well. So now that we have understood about the company and the products, we will just now, I'll take you through some of the fundamentals of active compliant technology. It must be running your mind, what is this active, and how different is it from the passive? So in order to show you that, I prepared this presentation. So if you can see these videos on the right hand side, what you see is a passive method which is traditionally done using a force torque sensors that are available on every robot. Every robot manufacturer gives these force torque sensors whenever force control application is needed. But then you see the amount of time that is being taken in order to sense and then in order to make a movement by the robot, because here the sensing is done by the sensor, and that sensor has to be used by the robot controller to compute it, analyze it, and then you have to take it forward for the movement. So the movement is primarily controlled by the robot. So when it comes to active control, we have a direct control of the force. That is why, as you can see now, the high speed movement can be achieved. So our active compliant tool is 30 times faster when it comes to speed. So dynamic correction is happening. So it is independent of the robot. It's not dependent on robot control at all. Only the IO is shared between the robot and our unit. So when it comes to surface treatments, we have shown, and many applications we have proven, that surface treatment requires only one direction force control, and the correction happens in microseconds, and that gives a very high speed correction of the force, and at the end of the surface the force is being maintained. It does not mean that force torque controls are useless. No, not at all. The 6 degrees of freedom is definitely required for applications which are different, like which are for assembly, for milling and other applications. Definitely they are useful in that case. But when it comes to surface treatments, we gain an advantage in terms of active compliant technology. So we don't have any limitation. Whatever is mentioned here, literally you can use it for steel, aluminum, titanium, magnesium, carbon, the composites, plastics, glass. We have no limitation at all when it comes to material. So these are some of the pictures of the products that you can see. This is ACF and this one is active sensitive kit. And this is the belt grinder. And we have the AOK and AAK. And when it comes to the components, you can see that there is a flange head which gets fitted onto the robot, and that head is connected with a Ferrobotics control box by an industrial robot cable. These are the only 3 main components that come along with our package. And working principle wise, this picture shows all in all the direction of the force is depicted by the green arrows. That is the only direction in which the force is being applied, controlled and maintained. And the Ferrobotics unit itself has a stroke adjustment from 35 mm to 48 mm to even the maximum of 98 mm. We have various units for various applications. And robot per se is just a motion device for us. The blue arrow shows the direction of the robot motion. So robot is moving from point A to point B, while the Ferrobotics unit maintains the surface force by detecting and correcting. We have compensation for gravity in all directions, so this does not become a limitation at all. So this is one of the gains when it comes to active compliant tools that we have. So as far as the signal transfer is concerned, all you need to do is from the robot, you need to transfer the set target force and set payload as an input for the unit. And as a feedback from the ACF control, you get actual force feedback, you get actual position information, you get contact information in terms of 0 or 1, whether the contact is made or not. So this is all very simple to interface. So I also would like to show you this video, which will give you a lot of idea about what I spoke about so far. So as you can see here in the video, the robot is moving almost from point A to point B in a straight line. It is not changing its course of movement at all. Whereas the Ferrobotics unit is expanding and collapsing to adjust its stroke in order to ensure that the end force, whatever is commanded, like if you have commanded 40 Newton as the end force, set force, that is being maintained at the surface, immaterial of the profile, immaterial of the undulations of the component. This is the whole beauty of the active compliant technology. So when it comes to the product ranges, we have various models from 100 Newton capacity to going up to 800 Newton maximum capacity of active contact flange product. Strokes also we have up to 100 mm strokes, as you can see on your screens. Now interfacing, we also do not have any limitation on the make of the robot or the type of the interface that the robot manufacturer provides. If there is Ethernet in the robot, we also give Ethernet. If there is DeviceNet, we give DeviceNet. If there is Profinet or Modbus TCP or any other type of interface, whatever is mentioned on this slide, we are able to give the same interface for the definition of IOs. So now coming to the principle of working. So this entire unit works on the principle of servo pneumatics. So here is a media which contributes to the maximum force of the unit. So 7 bar pressure is what is required. 7 bar corresponds to the maximum force designated for the unit. And we need the quality of air to be very good, oil free, moisture free and water free. And we need a filter of about 30 microns. And all you need to maintain is only the cleaning of the filters regularly once in a week by blowing the air inside out. That's all is the maintenance that is needed once in a week, nothing else. And these are the signals that can be transferred. These are all IO configurable. The set target force, set F0, set TRAM and set payload. These are the information going to the flange controller, and as a feedback you get actual force, actual stroke, actual contact state, and the error code. So one of the most important functions which our unit gives is this TRAM. TRAM is a time interval in terms of milliseconds that is given from the point that the contact is made between the abrasive and the component. That is called as force zero level. From there to the force target level, the increment in force happens in a time span that is not immediate. It is with a time span designated by the TRAM. Similarly, when the contact is removed, also the touchdown approach is also like it goes down gradually. It does not immediately become zero. So because of this gradual increase and gradual decrease, you can absolutely have what is called a soft touchdown. This is same as aircraft taking off smoothly and landing smoothly. So henceforth, any surface treatment, because of this feature, you will never have a buffing mark or a grinding mark when the component is touching and when the component is leaving the component, the abrasive. So this is the picture of our control box. You have a dimension of 300 by 200 by 160, very compact, and it operates on 24 volts DC. So that is about fundamentals. Now I request Manohar to take over and show the videos so that I can explain the application wise.
Yeah, Raghu, here we go. Yeah, 1 second.
Thank you, Manohar.
One second.
Yeah. So these videos are basically in order to show you how different types of material, whether it is aluminum or steel or wood or ceramics, how different materials can be sanded and ground and surface treatment can happen.
Same. But application is there.
Example of how auto components can be used for buffing. Next video, please, Manohar. Manohar. Application where you can see the glass being ground. So this application is done by one of the integrators of Ferrobotics called MBR from Austria. So this is an architectural glass. So they used to use a special purpose machine earlier after we gave this solution, they're very happy and they're using it regularly. You can see the automated tolerance control and also how beautifully the robot is doing the grinding using Ferrobotics grinding tool. So you can achieve size control, you can achieve beautiful edge grinding also with this application. And it is faster, and it is very clean, very neat application. So you can also think about, anybody who is from the glass industry can think about implementing this for windshields, for architectural glass, for any other type of glass. Yeah, we have another application shown here. This application, whatever is seen here, is for the polishing of the wood material. So in furniture industry, people know that it is have mass production. Then this is an application that definitely improves the productivity, improves the quality, and also ensures that the 24/7 you are able to realize the same consistent quality and the productivity in wood processing. So here you can see the brushing unit being used for buffing and sanding. So there are many ways you can adopt the active compliant technology. In this case, ACF, active contact flange, is being used along with the robot to give a kind of surface finish what is required for the sanding of the furniture components. The next video, please, Manohar. Yeah, now that we have seen various types, then we have seen the metal and we have seen the glass, we have seen the wood. Now I also would like to take you through this, one of the beautiful applications of sanding application. So here you can see the robot is doing the sanding using Ferrobotics tool with an orbital sander of the bathtub component. So this is a ceramic application. So some of the other components that you can think of is like the wash basins and different sanitary ware components which are made out of ceramics. So here you get absolutely fine finish because this is a larger surface area and it creates a lot of dust also while the sanding is being done. So it is really like very dangerous for humans to work in ceramic industry. They're exposed to all the health hazards. So when you employ a robotic application like this, you're actually giving a lot of relief to the people who are working around this area. And it is to ensure that not only productivity, quality is achieved, but it is also to ensure that the lives of people is taken care of. And the job can be done very efficiently and very quick also. That is the beauty of the whole application. Yeah, thank you, Manohar. Can you please pass on the controls again on the presentation, please? Yeah. So thank you, Manohar, for running those videos. Now I will quickly take you through the Cobot application. So Ferrobotics has tied up with one of the abrasive tools manufacturer called Dynabrade from USA, and we have made the entire tool very lightweight, and it is made as a kit. So now it is called as active contact flange kit. And we have various different types of tools from Dynabrade to address various needs of the surface treatments. So these are some of the tools that can be fixed to the Ferrobotics ACF unit to make it as a kit. So they have been made in such a manner that they are interchangeable. Like once the process one is finished, you can attach another tool to do the next process and so on. So now you can see how the tool change can happen automatically by exchanging the same only the tool at the flinch. So now you can see the safety pin is removed and the person is able to remove the end tool of the finger belt sander and is going to bring in another tool and fixing at the same location and locking it because these tools are made to run using pneumatics. The same pneumatic connection is being used, and after putting the locking pin, you're ready to go. So these are some of the different tools that can be used. So this makes the entire application lightweight. You can use it with any lightweight, even 10 kg payload of the Cobot or the lower payload robots. So you can also see many other applications like this angular grinder being used. This is a kind of deburring after the machining or after the plasma cutting is done. You can see before and after. And similarly, another type of angular grinder can also be integrated. Yeah, angular grinders are popularly used for weld joint uniform grinding. These are the most rugged usages of our technology for achieving simple automation. Yeah. Then deflashing or deburring. Yeah. These are some of the die-casted products where you can make an arrangement with this grinding tool to do the deflashing after the die casting component comes out. So you can see before and after. Then the orbital sanding of wood. This can be the technology used for finishing of the sanding using ACF unit. So there you go. It's very quick and fast. So brushing. So here is an arrangement which is shown with a component being held by the Cobot, while the Ferrobotics tool is mounted on the floor with a stationary arrangement, and the force control is achieved. So you can have multiple tools around. If you have, let's say, process 1 to process 5, you can have multiple tools like this arranged, and component can be held by the robot. Then drill bits used for die grinding application. You can see this kind of bonded wheels being used for die grinding applications. Drill bit type of a tool that can be used. Various applications. There is no limitation. You can change the tool. You can have an interchanging of these tools, and you can even if somebody is good at integration, they can also make a beautiful automatic tool changer also with this same similar arrangement. They can develop it further. So these are some of the applications of Cobot that I wanted to tell you. So now thank you very much, Manohar. And now I would like to introduce one of our integrators, Mr. Tarun Khurana is from Nextgen Robotic Automation. So he comes from a background of integration, and they are already well versed in the industry. They are known in automotive industry. They are known in general industry for giving automation solutions. So now Tarun will be giving an overview of unboxing of our product and then giving you a practical guide of how to mount it, how to connect it, and how to use it for some of the applications. So yeah, Tarunji, over to you. Thank you.
Raghu, before we do that, we have the second poll question. Should we go ahead across?
Yes, we can. Yeah, we can have the poll question. Yes.
Dear friends, we have the second poll question across. Do you accept active compliant technology, that is the ACT technology, along with the robots, is going to solve many of your pain points? Do you agree, not agree, or still not sure? Let's have the opinion and see how it surfaces. Let's give another 10 seconds before we close the poll. Yeah, I close the poll now. So you have the answer there. It says 68% agree, 7% not agree, 25% not sure. So
Okay.
I think you still have around 30% to get convinced in the remaining piece of a portion of the time.
I hope so. I hope the show by Tarun will answer many of their questions as well. So over to
Yeah.
you, Tarun sir.
So I will run the
Yeah,
video
sure.
now. Okay.
Yeah. Here we are going to show you how AAK unit, active angular kit unit, can be mounted on the robot with ease, with very comfort zone. So it is taking very less time to also mount and integrate with the robot. Manoharji, can you just start the video?
Video starting.
This is Angular kit, and these are the cables which are coming from Austria: power cable, encoder cable, device net cable, which are to be mounted to the mechanical unit as well as to the robot arm. This is the amplifier unit from Austria, then power control card, device net. You can see all these cables we have to mount on the robot controller. This controller comes from Austria. These are plug-in type cables which are mounted on controller, and we are going to mount this mechanical unit on robot flange. It's too easy. We have to make a flange and mount 6 bolts on the robot to integrate. And you can see these 3 connectors. One is the power connector, plug-in type connector, then encoder, and this is a device net cable, and air connection. Air connection is required. 6 bar air, dry air is required for proper functioning of this tool. So and then we have to put this device called a disc, backup disc, and the abrasive paper. We can mount it with manually to mount on the robot arm. You can see. Depending upon the type of application, we can use the abrasive disc and backup pads. And after connection, we have to interface with the robot programming pendant. You can see in the micro job, we have to configure the IO in device net. The maximum force we can use is 160 Newton. You can see 4 parameters we have to set. 0, the required force, the RPM in the micro job. You can see now the practically after configuration of the force RPM, we can use it on the job. This is the bonnet of a tractor. After welding, we have to remove the welding marks through this grinding application. So at any point of time, we can increase or decrease the speed, increase or decrease of force in the tool. So we can play around with the configuration of force and RPM to get the desired results. With manual operation, it is taking almost 3 hours, but with robotic, it takes almost 15 minutes.
Which are being removed by the grinding, correct, no, Tarunji?
Yeah, yes. So this is simple to integrate with the robot.
Yeah.
Hello. So this is
Yeah.
basically, I have shown you how to integrate the AK unit on the robot arm and control through programming pendant.
Yeah, thank you, Tarunji. That was an excellent show. I think you gave a lot of overview on what is our unit, how it looks, how easy it is to integrate with robot, any type of robot, and also what kind of interfacing techniques are used to achieve the end result. So that was a very practical information. So thank you so much.
And thank you very much to Manohar ji, Sandeep ji, and Thomas for giving us the opportunity to be part of this webinar. Thank you, Raghusan.
Yeah. Yeah. Okay. So Manohar, shall I go ahead?
Yeah, you can go. Yeah.
Okay,
Or
fine.
we use
So now I think
Raghu, we just run the third poll question so that after this video we
yes,
get an idea on how the people feel about the integration of the robot.
yes, I think
Which,
it's a time
Carol
for
has created. Yeah.
it is a time for us to ask that question and then get a feedback. Yes, that is a first-hand feedback.
So you have the third poll, third and the final poll question on your screens. Do you agree that it is easy to integrate Ferrobotics applying ACT technology, that's active compliant technology with robots? It's easy to integrate and run it. Very difficult or difficult, sorry, possible with little bit of training. Let's see what the people say. Let's wait for another 10 seconds.
Okay.
So I close the poll question now and we'll share the results. So 51% say easy to integrate, 47% say it's possible with training. So they're split in their opinions. Well, there are very few people who said 1%. So that means people are accepting, yes, it's not a difficult choice. So now
So it's kind of a Trump and Biden fight that is happening. Okay.
It's over to you, Raghu. It's over to you. Yeah.
Okay, thank you. So I think it was fantastic. I think many people understood how easy it is to integrate it. So when it comes to India focus, we have all these sectors. We have automotive sector where we have various type of metals, ABS, plastics, carbon fibers, and glass. Electronics, mobile phones, laptops, LED monitors, the deflashing of them, TV screen, manufacturing industry where we can give solutions. General industry, architectural glass, then furniture industry, we have a lot of wood, aluminum, and steel being used. And sanitary waste, as I showed in the presentation, we can use it for buffing of the faucets, mixers, taps, door handles, and bathtubs and whatnot. And then the larger surface areas like the bus or the train body, we can do the sanding and polishing. Windmills, this is one of the beautiful applications to show how a labor-oriented application can be automated for blades sanding. And aerospace, of course, we have wings, turbines, and the blades, which can be, the surface treatment technique can be used with our technology. So wherever there is a high labor-intensive job, all those areas are definitely suitable for automation with our technology. So now the next question will be how to coordinate and who is going to answer to the queries, or who is going to take it to a level wherein the pain point is addressed. So the first thing is that those who are interested can come in contact with us or with our authorized distributors and robot integrators across the country. And we need to actually arrange a demo, and we need to, before doing that, we need to identify and choose the right applications where the trials can be conducted to realize the importance of this technology. And it is our job to ensure that the benefit calculations or the ROI is being calculated and properly brought to the attention of the decision makers, so that they weigh between the labor cost and the automation cost to see how the productivity and quality aspects are realized. And taking trial and getting convinced is the key for us, and we have the Ferrobotics solutions to ensure that most of the operations that call for human intelligence in terms of tactile sensing are automated using our ACT products. So partners in India, we have Nextgen Robotic represented by Mr. Tarun Khurana here now, and we have GK Machineries and Robotics from Bangalore, and we have Natasha Enterprises, who is our distributor from Delhi again. So that comes to the closure of our presentation. I thank you all very much, and Manohar, over to you.
Thank you, Raghu. It was very interesting presentation from your side as well as Tarun, and also very insightful talk in the beginning from we had from Mr. Conrad, and it was very interesting. I'm sure the participants would have liked all your the detailed talk of your presentation. There are a lot of questions, and let me ask you all one by one. So the first question I would say is to what, just to you across, Raghu, can Ferrobotics products be used with spindles for flashing?
Yes, of course. The question is very relevant, and this shows that people are definitely recognizing our technology. Spindles can definitely be connected with our Ferrobotics technology, whether it is the cartridge type spindle which are used for typically mounting a buffing unit or a polishing unit. Those spindles can be definitely used. And we have the Ferrobotics ACF units which can carry weight up to 15 kgs to 45 kgs also. For example, the 800 Newton ACF can carry a weight of 45 kg. So you can literally mount a full-fledged, even dual shaft type cartridge type spindle motor at the end as an end effector for polishing applications. It's a good question. Yes, it is possible.
Interesting. Another question we have across: what is the maximum speed that can be achieved with ACT tool for deburring?
Well, I would like to.
Yeah. So the speed.
Okay, is it a question for me?
Yeah, you can either you or Tarun, neither of you can answer.
Okay, Tarunji, would you like to answer this
yeah, up to
query?
10,000 RPM, up to 10,000 RPM maximum, we can use this tool.
You can use 10,000 RPM. Very good. So let me ask another question to my Thomas this time across. Thomas, to your question, how do you see the prospects in the Indian market across?
Well, basically, the Indian market is already is important for us, but will gain even more importance in the future because there's quite a lot of changes are happening, especially looking into areas like transportation or now also assembly for electronics and whatsoever, just to pick a few. And they're very positive trends and gonna be very important.
Good. Thank you, and I'm sure that you would be laying a lot of emphasis on the Indian market across. Yeah. Another question, Raghu, to you. What are the maximum Rmax and RL values that can be achieved?
Oh, you can achieve whatever is the best. You know, even the RA values of grinding finish, you can achieve. The surface glossy finishes can be achieved. We have done mirror polishing. We have done mirror polishing on stainless steel. We have done mirror polishing on aluminum components. Even aluminum is one of the most trickiest metals where mirror polishing has to be done, because even if you touch it by hand, you have that mark coming on the component. It is so soft, but we could achieve. So any type of any RA values that you desire, it is possible. But you need to also have abrasives to be conducive to achieve the RA values. It is not just the force control unit. You also need to ensure that the proper abrasives are employed, whether it is a cloth buffing unit or a brushing unit. All those things, it is a process. It's a process-driven achievement. You cannot use one type of buffing tool and simply get RA of 0.2, for example. You have to have a process-driven approach. You have to do buffing first and process 1, process 2, process 3, like that. The cloth buffing, you have to use abrasive soap or abrasive paste in order to get the RA values as desired. But there's no limitation. Yeah. Thank you.
Yeah, connected to the same, Raghu, I think I'll continue with you. Connected to the same question is, since you mentioned it can be abrasives are the important key points in the, for the tool.
Yes.
Can scratches on the parts, random scratches, can be scanned and buffed automatically?
Thomas, would you like to answer this query?
Yep. Thomas?
Sorry.
Thomas, the question is, can scratches, when you say scratches or basically some roughness on the parts, randomly can it be scanned and buffered automatically? Can it sense these scratches randomly, or is it follows a defined path in the process across?
Well, depends, of course, on what the part is and how it looks like. Basically, our equipment itself cannot scan it.
Yeah.
But with auxiliary equipment or other equipment, it would be possible. There is already quite some work ongoing by some of our partners on scanning and sending. But on the other hand, it's also a question, is there really a vision system or something like this necessary? Or can we anyways address it with our equipment, with our technology? Because there is quite a big difference between a manual sanding job or polishing job and an automatic one. This is very hardly to compare. That's why, yes, it's possible. Does it make sense? It's a case-by-case decision.
Yeah, so with an auxiliary system, you can definitely do this activity. That's what you're trying to communicate. Thank you. Tarun, to coming across to you, what is the average size or weight of a component for which Ferrobotics can be used for buffing?
Average size of?
Average size or weight of the component for which the Ferro products can be used for. Yeah.
Component weight can be anything, but only thing is the Ferrobotics tool, which is going to mount on the robot, that is maximum 8 kgs. The component size can be anything. Yeah.
Okay. And
so adding to that, Manohar, Tarunji, adding to your comment, basically there are two arrangements. The tool can be held by the robot, and the component can be stationary. So when the component is stationary, there is no limitation whatsoever on the size or the weight of the component. The size of the component is reached by the robot, the size of the robot that you choose.
Absolutely.
The weight does not, it does not matter at all, because the tool is held by the robot. But in cases where some of the cases, like the video one that I showed, the robot is carrying the component and the buffing tool is stationary. In such cases, you need to choose the right payload of the robot in accordance with the weight of the component.
All right, I think that's well answered. I think I'll come back to Tarun again. Tarun, how efficient will be the buffing process when there's a high volume production of components?
For high volume process, I think this AAK tool is very important, and it can be used because it can, with manual operation, it will take almost a fraction of seconds to do the buffing of in automation system.
All right. There are still a lot of questions pouring in. I think I will go in for a last round, and I will leave the Ferrobotics team to answer the remaining through their own self when we share the details to them. So coming back to you, Michael, the last round of question. What is the typical ROI for automation of surface treatment application when changing over from manual process to automation process? What a typical ROI would you look at it across?
So this is a question to Thomas, I guess. Yeah.
Thomas, would you want to answer it, or do you want?
Sure. Well, it's hard to make a general statement on return of investment and amortization of the equipment, but of course depends on the application and whatsoever. But to give you some numbers to work on, if we talk about amortization of the system, can be somewhere as short as a few months up to something less than 2 years. If we talk about real ROI, let's say after a couple of years, it can be up to 20%. So it depends on the application, and as I say, it's a case by case. But that's why we are happy to look into that and make a benefit calculation.
Yeah, that's good. That's
Yes.
good. I think Thomas will have answered it from a very bigger perspective. Would Raghu, do you want to narrow it down to a bit or more on Indian perspective?
Yes, in addition to what Thomas expressed, typically in Indian conditions, we have the labor costs which are on an average, they are affordable labor costs. So we tend to normally calculate the ROI with respect to the labor costs alone. But I would say that we should not do that alone. We should also take into consideration the percentage of rejections that are getting reduced. That is adding to the productivity, and the cycle times that are being consistent, the output being consistent, the productivity bonuses that you get by running it 365 days without taking any kind of tea break, coffee break, or any kind of breaks. So you are employing a robot for this kind of surface treatments, which is highly efficient. So taking that into consideration, and an average, a typical surface treatment job which is replaced by the work done by 10 workmen to one robotic cell, you can say the ROI will remain on an average within 2 years.
Okay, that's fantastic. So coming and staying with you across the, can we, with you Raghu, can we operate a multi-tool with different abrasives at the end mounted on the robot?
Yes, that's an excellent question. We can make what is called as a tool changer mechanism. That can be, of course, in the scope of the integrator. We have our integrators who can also give that kind of solution. So when one single unit of Ferrobotics is there, multiple tools can be picked automatically to do one process to the next process to the next process for the finishing. So you can have the automatic tool changer mechanism for that, whether it is a different type of abrasives or even the disc changing mechanism. See, for example, when you're doing a grinding of something like a fuel tank, for example, each of the disc will be sufficient enough to do 10 numbers of fuel tanks or 15 numbers of fuel tanks, for example. After the disc loses its life, you need to automatically make a change of the disc. So we have solutions to automatically change the grinding disc also. So yes, the question is very relevant, because in a highly productive environment, you also need to exchange the tools. You also need to interchange the old abrasive with the new abrasive disc. It's very relevant. So we have the solution.
Yeah.
Definitely.
Coming back to you, Tarun, the final question is, can Ferrobotics be used for car seat belt buffing and gear levers?
Yes, it can be used.
Okay, good,
Yeah.
good. So, friends, we thank Raghu, Mr. Thomas Conrad, and Tarun for wonderful insights on the new trends of automation that's going to go in the industry, especially in India, how it can be beneficial to the industry. So I'm extremely thankful to Thomas, Raghu, and Tarun for their insightful presentation on highlighting surface treatment in a new phase of productions on using active compliant technology that can be highly efficient, and it would help in immensely saving the benefit. We saw Raghu and Thomas both explain the ROI on this, and they will be highly reliable, flexible, and ensuring precision in their products and reduce reduction quality. Friends, as the next wave of automation is going to continuously cement across the manufacturing industry, we will begin to see transformation like never before. Machines will not only collaborate with humans in the workplace, but they will also help to revolutionize the job skills and skill sets that humans cannot adopt. Although robot density is very low in India, but it is going to continuously increase in the future. The pandemic currently prevailing would act as a catalyst for automation in India, which, as explained before by Sandeep, is going to increase the contactless manufacturing, and Ferrobotics products and the robotic solutions are going to be a tool for improving production in the contactless manufacturing era. Friends, thank you. We had an immensely large number of participants. We had more than 120 plus people attending this webinar today in large numbers across wide sector of the industry, right from woodworking to glass industry to auto industry to ceramic industry. So a lot of people participating. I'm sure they would have immensely benefited this. And we'd like to once for all thank you, Raghu, Tarun and Thomas for actively participating in it. I would
Thank
like
you.
to thank my colleague Cindy and also my colleague Ashita, who was behind this activity for mobilizing people, and of course Ishan also for helping me out. So I'm extremely thankful to all of you, and I would request, most important, you people who participated in such large numbers and have immensely benefited from this webinar. I wish you all a happy day today and also a relaxing weekend. Be safe, stay optimistic, stay well, and stay healthy, and have a great weekend. Have a great day. Bye-bye.
Thank you.
Thank you
sir.
very much. Thank you, VDMA. Thank you, Manoj. Thank you, Sandeep, and entire team of VDMA for this. Thank you.
Yeah,
Thank
thank
you.
you.